Started here, we'll start our recording. And once again, welcome everyone to our first severe weather Q&A webinar. We've done Facebook and Twitter question and answer sessions. We've done Facebook Live a few times. We really like this format. It's been really successful for us with our first 3 virtual storm spotter training sessions this season and the ones that we had last year. And we're so happy to be joining you tonight and for you to join us. And this is special for Illinois Severe Weather Preparedness Week, our Severe Weather Q&A webinar. And we'll be going until at least 8 o'clock. And if you're just joining us right now, we're very happy to have Dr. Victor Gensini from Northern Illinois University, their atmospheric science and geography department, a great friend of the National Weather Service, has worked with us in many aspects of what we do in the research field, even helping out with storm surveys for tornadoes, and also helping us out with hosting some of our awesome past event write-ups. So, I have a couple slides, and then we're going to hand it over to Victor, who's going to show some content about severe weather meteorology, a little bit of an outlook moving forward here this spring. I'm sure a lot of you are interested in what might happen severe weather activity wise over the next couple months. So that's what Victor will be doing. Then we'll open up to your questions. And once again, you could ask us questions in this interface. You can type them directly out to us and you could start asking your questions. And I'd invite you to see some of the content that we present, and that you can kind of see how things are being guided in terms of overall content. General severe weather questions are certainly fair game, and meteorology, preparedness, sheltering, proper sheltering from tornadoes, etc. So, and so we're in Illinois Severe Weather Preparedness Week through March 5th, and then in a couple weeks, if you're on here for joining us from Indiana, Indiana Severe Weather Preparedness Week is the week of March 14th through March 20th. And I have some links here, and once I go to them, I'm going to click on these. Hopefully I don't have any issues showing this part of my screen. I'm going to show you our severe weather preparedness page, our past events page, and some NWS safety pages that you can refer to safety information for. Also, we shared with you a link to a Facebook post we just made with a bunch of tornado sheltering graphics. So if you have any questions on that, you might find the information you need on there. You don't have to be a Facebook, you don't have to have a Facebook account to click on that link and see those images, and they're shareable, downloadable. So so whether you're joining us on Facebook, Twitter, or you don't have one, you can click on that link to see those graphics that I curated from our severe weather preparedness page. And I'm going to click on this our severe weather preparedness page that the link would work. Let's see. And if it doesn't work, we'll probably have those links sent out to you. It looks like it's spinning, so hopefully working.
It never works when you want it to work, Ricky.
Exactly, right? Okay, let me switch over to my browser. I have pages up already, so I'm going to move it over and move it onto this side of the screen. Thankfully, I had a backup. So here's our here's our severe weather preparedness page, and it's weather.gov/LOT/ and these are / severe prepare. And we have a bunch of graphics. So not just the ones that I shared on Facebook just now, but these are excellent graphics, and some of these are also available from the NWS comms team on some of their websites as well. So, but we've put some of the best ones together on our page, and it's tabbed interface, so you can just click those and see the various items on here. So some various safety information. What can thunderstorm winds do? What can hail do? What is a tornado? Some general safety images here, warning reception, and some local information here. A PSA we put together back earlier in the 2010s about Tornado Ready Chicago, and some other links. And these are some of and this is the NWS Spring Safety Campaign. I have up I believe I have up a page. Yeah, I have up. This is social media for this spring. These are some new graphics. One of the graphics I just posted on Facebook is your safe place from tornadoes. They followed a safe place theme for this year's spring safety campaign. And these are all downloadable images. So if you go to spring safety campaign, you could get to these images as well. Tsunami, I guess if you're heading out to the West Coast, extreme wind. So, and then the weather.gov/safety pages. If you just go here, weather.gov/safety, it provides all the various topics that we're going to cover. So lightning being one of them, and you can find lightning safety information. Tornado, I know a lot of people are interested in tornado safety information. So weather.gov/safety/tornado. You can also just type in weather.gov/tornado on your browser. And so those are just some links that I wanted to share with you. We'll be able to go over items on our website further if you have questions about them. I don't want to take too much time up right now before Victor's part, and I'm going to go back to my slides and show you who's your host. Oh wait, sorry, I'm not a cat. That's me. Ricky Castro, one of the forecasters here, and we're located in Romeoville in northern Will County in the southwest suburbs of Chicago. And then we have Matt Friedlein from Mendota, the little big city of Mendota in northwestern LaSalle County. Born and raised, and an avid goer of the Sweet Corn Festival that hopefully should be back strong in 2021, hopefully, God willing. And then we have Jake Petr, one of our newer forecasters. So that's who's joining you on the line from NWS Chicago. And then we have Victor from Northern Illinois University. And I'm going to hand it over to Victor now, and he'll take it over for the next 10 to 15 minutes. We'll open up for questions at that point.
Great. Thank you so much, Ricky. I'm going to go ahead and get my screen going here.
And let us know if there's any issues on that.
No, I think we should be okay. You should be seeing my title slide, hopefully. Let me know if that's not the case.
I see it.
Okay, I think we're good. Ricky, thank you so much. And thank you all for hopping on the line in what seems like the ever eternity of winter of our February. You know, we had an incredibly mild winter, and then we went into this death spiral, it felt like, as we went through February. In fact, in early January, we had an unprecedented period of freezing fog in north central Illinois. We had about 6 days back to back with freezing fog, which is actually a pretty common phenomenon in northern Illinois, but not during that time of the year. It's usually a phenomenon that happens around now, late February, early March. So that was interesting. And then now, of course, we're melting all that snow. And if you've looked at the extended range outlooks, the next 10 to 14 days look unseasonably warm across the Midwest, including northern Illinois and northwest Indiana. So spring is certainly here, and it's no better time, I feel like, with these warmer temperatures coming than the beginning, right, to talk about the preparedness for severe weather. So I don't have a ton of content tonight. I do have some things I'd like to share with you that are a little bit more educational. I do want to briefly talk about the outlook, the large scale outlook for tornadoes this year across the United States. And then really we're going to open it up to questions and answers where we really want to hear from you, make it interactive where you can chat your questions into our team, whether it's science-y questions that you want me to focus on, forecasting questions, or questions from our folks at the National Weather Service about safety and weather preparedness week, or really just the forecast process. We'd certainly be interested in answering all those questions. So without further ado, a little bit about me just very, very quickly. Many of you will remember, especially for those of you who live in far southwestern portions of the Illinois, the Chicago County warning area. This is in the eastern portion of Davenport's warning area. It's really where kind of the 3 county warning areas meet. You're zoomed in here on the border of Putnam County and LaSalle County. This is the April 20th, 2004 tornado track that started southwest of Granville and then moved across the Illinois River actually in 2 spots before impacting the town of Utica and unfortunately killing 8 people. And this particular storm, you'll see the path here on the north side of Granville, impacted my high school at the time, and really is the reason why I chose a career path in meteorology. And now I'm full circle back teaching classes in Illinois, and I'm an Illinois native. I grew up actually in Putnam County, so just outside of the Chicago National Weather Service County warning area. But this particular day has always interested me because we see a lot of tornado events in Illinois that are near these warm front features. And I want to talk about warm fronts more, probably maybe the most when we get into the discussion section and answering your questions. But these warm fronts are generally prolific tornado producers, and you'll see some of the statistics that I have about warm fronts and their impact on the northern Illinois tornado climatology. In fact, I like them so much, you can probably imagine I'm a pretty big weather geek, as maybe many of you are, tuning into a webinar on a, what is it now, a Tuesday evening to learn about severe weather preparedness and safety week. So this is my annual Halloween costume with a warm front on my left arm here and a cold front along my right leg. You could certainly say that I'm a weather geek like many of us at the Weather Service, and I'm fascinated by everything extreme weather, including severe convective storms, which is really the focus of this week in Illinois and 2 weeks from now in Northwest Indiana. So very briefly, just severe weather 101. What does it take to get a tornado? What does it take to get severe weather? Just like baking an apple pie, you must have certain ingredients. For tornadoes, we must have, the acronym here is SLIM. We have, let me get my little marker up here so I can draw. Hopefully you can see my annotation here. We need shear of the wind, something to lift the air parcels to get them rising, instability in the atmosphere. Think of those days when we've had severe weather in the past. Go back to last year, the day of the derecho, August 10th, 2020. Think about the amount of instability in the atmosphere. You walk outside and it feels like you can't even sweat because it's so humid and so hot. If you build up that instability and moisture, that's really the gasoline for these tornadic thunderstorms to form. And if you only have this, then you'll only get ordinary thunderstorms. You must have the S component, this S in SLIM, which is shear of the wind, to be able to create these tornadic storms. And really the most damaging of all thunderstorms, which are, you'll see if you read the area forecast discussions from the Weather Service, they will be mentioning the possibility for supercell thunderstorms. Those are the ones that are rotating, have what we call areas of embedded low pressure mesocyclones. And those are the ones that have produced majority of the severe weather. In fact, if you do some very basic research here, take all of the severe weather events and plot them on an XY chart where the x-axis is that instability parameter and the y-axis is the wind shear, what you'll start to see is that all of the severe weather events, the really bad ones, your EF2 tornadoes, your baseball size hail, your 80-mile-per-hour plus wind gusts, they all land up here in the upper right of this graph, meaning that they basically are characterized by environments here that have a significant amount of instability in the atmosphere and a significant amount of vertical wind shear. So when you have those two parameters, you're likely to get supercells. There obviously are other ingredients. Tornadoes are very Goldilocks. They don't like too much of one condition and not enough of another. But on a very basic level, if you have a lot of instability and a lot of vertical wind shear, you have the possibility for these significant severe weather events to occur. And so if you plot those environments globally, here's where we see tornadoes across the globe. We don't have records everywhere. Certainly there's not folks floating around in the Pacific or the Atlantic Ocean taking measurements for us. We use reanalysis for these types of data sets. But you can see that tornadoes are generally a mid-latitude phenomenon. When I say mid-latitudes, I'm primarily showing you here between about 30 degrees north latitude and 60 degrees north latitude, and then 30 south to say 60 south. They're in these mid-latitude bands. You don't find them near the tropics and you don't find them near the poles. And a lot of people like to say, well, that's got to be where the warm and cold air clash. And in some ways, that's an adequate, maybe an adequate story to tell somebody. That's just the warm air from the south and the cold air from the north, right out of Canada, and then your warm Gulf of Mexico air. In some ways, boiling it down at the end of the day, that is what's happening. You have a lot of instability, but there's a lot more than that. There's wind shear at play. There's got to be enough moisture. There's got to be even rotation in the atmosphere for these to form. But certainly, if you like tornadoes and you find them fascinating, you're living on the right continent. North America, by far and away, sees more tornado environments than anywhere else globally. Although there are some other hotspots, we see just really on the leeward side, or here the downstream side of the Andes Mountains, in portions of Argentina and southern Brazil, portions of South Africa, Australia, and then actually another very interesting hotspot is in Southeast Asia, and portions of the Asian continent. In fact, Bangladesh is an area that sees a lot of tornadoes every year, although many of them are not, what I would consider to be impressive and strong. They still do see a lot of tornadoes. One question that I continue to get from the media and a lot of people in the audience is Tornado Alley shifting? And we came out with some research a few years ago that sort of showed the trends in the number of tornadoes that locations are seeing across the United States. And so I wanted to make a couple clarifications here, because there's a lot of, I think, misconception about what's happening in the tornado trends across the United States. First of all, if you see the negative numbers here, this does indeed say that the favorable days, the number of days that we see tornado watches, for example, the number of days when the conditions are favorable, is definitely holding steady or slightly decreasing in the Great Plains. And when we think about Tornado Alley as sort of a media-derived phenomenon, you're really generally talking about this area that I have highlighted: your Kansas, your Dorothys, Oklahoma, Central Texas, Nebraska, and South Dakota. When in reality, if you look at the significant tornado climatology, it actually looks something more of like a C shape, like a Pac-Man shape over the United States. And so there's some, I think, misconception about exactly where Tornado Alley is located. And I'm actually not a fan of Tornado Alley. I think it's a really misleading term. Tornadoes can happen in all 50 states, including Alaska and Hawaii. And for that matter, they can happen any time of the year. It can be January, as long as you have those ingredients: shear, lift, instability, moisture. That's all you need. It can be February, it can be March 3rd. It can be March 3rd tomorrow, right? And we could have these ingredients in play. So let's talk a little bit about let's look really quickly at last year, and then I want to focus on this year's forecast. So 2020, when it was all said and done, was fairly average. Average by the count metrics of significant tornadoes, average by the count metrics of just normal tornadoes. We did see a lot more tornadoes in the eastern United States than we saw in the Great Plains. In fact, the Great Plains were fairly quiet. And if you look at this is basically a graph that's accumulating the number of tornado reports on the y-axis here with respect to time on the x. So basically, as you go out through the annual cycle, the year, you can see where your big tornado days are, right? Wherever you have these big jumps, those are the days where you accumulate a lot of tornadoes. So you can see here in early to mid-April, we had a pretty active period. We had one day with over 160 tornado reports. That put us above average for a while. This black line here is the 10-year average. So whenever you're above that black line, you're above average. Wherever you're below. So you can see we finished the year with preliminarily 1,245 tornado reports, when we should expect on a normal year about 1,400 across the United States. So slightly below normal, although for all intents and purposes, we're pretty close to what we would consider an average year for tornadoes across the states. Now for hail, totally different story. We actually were way below average. In fact, we nearly set the record in 2020 for lowest number of hail reports in the modern record since 1995. A lot of storms there. We still had lots of thunderstorms. They still produced tornadoes. Not a lot of hail, and not a lot of significant hail. Hail being 2 inches or greater in diameter. So we're still kind of head scratching, what was going on last year in terms of lack of hail activity. And you can see there was just really throughout the entire year, we stayed well below that average, that 15-year average line, which is something, again, that every year we get this new data set, and every year we're going to relook at the historical conditions and try to figure out what happened. Let's focus on this year really quickly. There's been a lot of news stories coming out in the last 2 weeks. Severe weather season is going to be incredibly active. I was just did an interview today I did an interview yesterday for WBBM Chicago. I did an interview for the Washington Post. I've been talking to reporters who are really interested in this problem. You know, what is the spring going to be like? Really, at this stage, the only thing that we can hang our hat on right now are what we call ENSO, the El Nino Southern Oscillation. And the El Nino Southern Oscillation is sort of a very special phenomena that happens in the Earth's weather and climate system. And it all has to do essentially with water temperatures in the equatorial Pacific Ocean. So right, here's our geography. You can see the North American continent. You can see Asia. This is the Pacific Ocean. And what we're really focusing in on is in a rough area that I have outlined in this box. This is called the Nino 3.4 region, roughly speaking. Now, in that region, you'll notice we have blue colors here, and these blue colors correspond to colder than normal water temperatures. When the water temperatures in this region are colder than normal, we say a La Nina is in effect. La Nina and El Nino are actually of Spanish origin. They originate from Peru and Ecuador in South America, actually relate back to the fishing industry. When El Ninos were in place, they had really terrible time, very difficult to catch fish. When La Ninas were present, they see upwelling of water in Peru and Ecuador across the Peruvian coast, and the fishing industry during La Ninas flourishes. So that's sort of the origin of the word. But what we really look for as scientists are water temperatures in this area. And what that will do is really alter the jet stream patterns across North America and South America, the Southern Hemisphere as well. And really either produces conditions that are favorable for tornadoes or tend to mitigate tornadoes. If you look at the research, which I'll show you on the next slide, La Nina typically favors active severe weather seasons in March, April, and May. So the top panels here are basically hail anomalies, where if we have blue on the map, we see below average there. Okay, if we have red on the map, that's where we see above average activity typically during a La Nina. So for hail and an El Nino, we're pretty widespread below average across the majority of the country here. When you look at El Nino during March, April, May for tornadoes, it's a mixed signal, it's a mixed bag. But I would say if you look at, majority of those grid points, they're below average. When you get to La Nina, look at hail and also tornadoes for La Nina. When you see the reds, you're talking about, greater than what is typically seen, greater than average. We call these positive anomalies. With hail, we tend to see a greater activity in the southern plains, and for that matter, a majority of the continental United States. And La Nina tornadoes is probably the greatest signal out of any of these panels that generally suggests a more active southern tier of the United States and portions of the Mid-South. For the Midwest, you can see it's sort of a mixed bag up here as you get into northern Illinois. I would caution you, these grid boxes are, pretty large areas, and regional trends are pretty difficult. You want to kind of stand back here and take a 30,000-foot view at what these charts are telling you. What they generally say is that during La Ninas, we tend to see active March, April, and Mays, especially March and April's during these patterns. And finally, before we start taking your questions, I want to just briefly discuss when to be prepared in Illinois. This is obviously Severe Weather Preparedness Week. We're really excited to begin getting that message out. If you look at the forecast over the next couple of weeks, it's going to be warm. And when it's warm in March, you have to start thinking about the possibility of severe weather. All it takes is a little bit of moisture, and you have that instability that you need, because as you know, in March and April, all of that wind shear is still here. It's still hanging around. The hardest thing to get this time of the year is that instability that you need to get that hot air balloon rising. So here's some research I did many years ago. This is old now, I need to update it, but I guarantee you the stats are the same. About 7 out of 10 tornadoes in northern Illinois come during April, May, and June. So you can see, why do we do Severe Weather Preparedness Week in early March? Well, we get tornadoes in all months, but this is the month where we really begin to accelerate that count, that total. 68% of all of our tornadoes that I looked at through that period were happening during April, May, or June. In fact, you'll see here in a minute when I show you a really great web page from the Storm Prediction Center, the peak climatology for Northern Illinois is actually the first week in June. It happens like right in here, right in this time frame when you look at peak climatology. Something that I'm not going to discuss necessarily right at the moment are, and I welcome questions about this because this is a fascinating thing that happens, and it's very unique to the Midwest, especially in Illinois, is the importance of warm fronts. And we can go through what warm fronts are later during the discussion section if you'd like. But these warm fronts are generally prolific tornado producers in the spring. When you think back to the Utica tornado in 2004, if you remember the Streeter tornado and Magnolia events, I believe it was June 5th, 2010, June 22nd. Ricky's the one who knows all the dates. I'm sure he could rattle them all off to us. But the point is, even if you go back to Palm Sunday, right, 1965, they're generally there. They're not there for all events, but in the spring, they're generally there. They create a unique combination of ingredients that are very favorable for tornadoes. And if you look at the warm front tornadoes that we've had throughout this climatology from 1970 to 2011, we get about 3 of these events on average a year, and that's aggregating for all tornadoes. My final message to you before we start to take questions is it doesn't matter if we're in an El Nino or a La Nina or what we call ENSO neutral, where there's no signal at all. All it takes is one tornado to make your day a really bad day. This is some research from my colleague at Northern Illinois University, Dr. Walker Ashley, who was really the pioneer for some of this work that has looked at, in particular, what is becoming an increasingly challenging issue across Northern Illinois due to the expanding Chicago metro area, especially on the western side, what we call the areas of greatest urban sprawl. If you think of Chicago sprawl, it's happening out here in Kane County towards DeKalb County, and really on the southwest side of the suburbs as well. Places like Plainfield that in 1990 had a very, very small population and are now booming suburbia, right? And so the idea here is that if you have a historical tornado path in 1950 that didn't really affect much in the future, and certainly as we go forward in populations and the urban footprint continues to grow, we are going to have more and more of these tornado disasters. And again, it only takes one. It only takes one. This could be, a relatively quiet year, and then all of a sudden you have a Plainfield, all right, in August 28th, 1990. That's all it takes. It takes one event. It doesn't have to be Nino, La Nina. That's why we really harp on the preparedness to have a safety plan and make sure you have redundant ways, right? Ricky had that browser up just in case. He clicked on the link earlier and it didn't work. He had a backup plan. Have a backup plan, have different ways to receive warnings, and pay attention to forecasts from the National Weather Service because they are the ones that are looking at the forecast day in and day out. And really providing those messages to you. Know the difference between a watch and a warning, right? We can answer those questions as well. So that's it for now. I have some more slides that I've saved here that focus a little bit on the warm front aspect, so maybe we can talk more about that. But at this point, I'm really going to stop sharing my screen, and I would really be happy at this point. We have 30 minutes or so, and we can stay a little bit longer if we need. But we really want to open up the floor to questions. Questions about, I hear these all the time, right? Urban myths, urban legend, what corner of the house should I shelter in? All these kind of things. Hopefully the idea of how active this season is, we're really going to start. That's the seasonal forecast. I didn't mention the sub-seasonal aspect is where we begin to look 2 weeks out, 3 weeks out to be able to try to predict how active things are going to be. But I can say that the tea leaves that I'm looking at right now suggest a pretty active March. And that does include, we cannot exclude Northern Illinois and Northwest Indiana from that outlook. So as the temperatures get warmer here and as we continue into March and that sun angle begins to get higher and we get more and more instability, so too will the climatology and the frequency of tornadoes and hail begin to really rear back here across the Midwest. So what a better time to begin talking about it now during Severe Weather Preparedness Week. So thank you all so much for joining us. And at this time, I'd be happy, along with the other folks from the Weather Service, to begin answering any of your questions.
All right, thank you very much, Victor. Here we've got a bunch of questions coming in, and just a reminder in the little questions interface there on the GoToWebinar, you can enter your questions there. And here, Victor, Jake and I are monitoring. One question here, and I may answer this, Victor, give you just a short break. One of the ingredients Victor mentioned was instability. That's key. And as forecasters, an indice we look at is called CAPE, Convective Available Potential Energy, it stands for. We like acronyms in the meteorology business, as CAPE is one of them. This question asked, what type of instability do we like to look at, surface-based or mixed layer? And there's even other types that we looked at, including most unstable, for instance. And it really depends on the situation. Victor showed some of the climatology, and often in terms of a temporal aspect, our time of day of tornadoes mid-afternoon through early to mid-evening. That's sort of our peak there. And that's basically the peak heating of the day and just shortly after. And it's a time when that rising air motion Victor talked about due to the heating of the day occurs, and our atmosphere becomes well mixed usually. And so the mixed layer CAPE may be more of a preference, especially for that time of day, but it depends on how we expect the atmosphere to evolve too. And so if you read our forecast discussions from the National Weather Service, accessible from our homepage, you can learn more about those indices and how we're monitoring them. When we're looking at nocturnal thunderstorms, we're often looking at elevated instability or elevated CAPE, for instance. And so it depends really on the situation that we expect there. But that was one good question we had. We've had a couple questions here, Victor, on the derecho last year was obviously our biggest event in Northern Illinois and the Corn Belt as a whole. Based on your research there, Victor, you showed sort of tornado trends. Is there any potential for derechos to become more common? And also just derechos in general, what makes them so long-lived as well?
Fantastic question. In short, we do not have the same evidence for shifting or changing frequencies or intensities of derechos at this time. And I'll tell you, when the major reason we don't is because the history of reporting damaging wind across the United States is relatively poor compared to the tornado reports that we have. If you go back to even the late 1800s, we were actually keeping pretty good tornado records. Now, the tornado had to hit somebody or hit a farmstead, right? Especially in the late 1800s, or as you get into, the Homestead Act in the 30s and 40s, there had to be some damage. It had to get reported in a newspaper, and then it goes into the record. But generally speaking, our tornado record is actually much better than something like the hail or the damaging wind. We really didn't start keeping good records with damaging wind until the modernization of the Weather Service in the mid-1990s. And so we don't have a long enough sample size to really say for sure what's happening with derechos. What we do know is that if you had to pick a place in North America that experiences more derechos than anywhere else, that place would be DeKalb, Illinois. North Central Illinois is ground zero for derecho frequency. When you look at the climatology of where these long-lived windstorms occur, they're incredibly impressive, long-lived, can produce winds and damage that rival weak tornadoes. And in the case of last year, you can even get damage that rivals significant tornadoes in the case of places like Cedar Rapids, Iowa. So, they are, I think, an underappreciated hazard. And certainly last year's derecho is going to end up costing more than all of the tornadoes probably last year combined. That event is easily going to end up as a $10 billion loss when you count in all the damage to residential, commercial properties, and agriculture. That thing raked through the heart of the Corn Belt when the corn was really at peak maturity. So that, no doubt is an unprecedented event. I hesitate to say unprecedented. It was impressive, but I don't think it was unprecedented. These derechos are actually fairly common across the Midwest, And, you know, if you look at the climatology of them, yeah, that was probably maybe a 1 in 15, 1 in 20 year event. But, you know, when you get more instability, we have one thing that really helps those types of situations is that we have a lot of corn and soybeans, especially in late summer. And those corn and soybeans, we have what's called transpiration. They basically evaporate moisture into the lower atmosphere. And if you've ever gone out near a cornfield in the early morning in the summertime, and I'm sure Matt can tell you this, being from Mendota, if you've ever detasseled corn before, you know that early in the morning, there's just this corn sweat and corn fog, heavy, you know, air feels heavy. It's actually, that's a misnomer. The air is actually very, very light. When you have a lot of water vapor, actually the air is less dense. But when you have all that moisture in it, it does create all that fuel that you need that's necessary for later in the day for those thunderstorms. So great question. Derechos are definitely an under-depreciated hazard, and they can be, in the case of last year, just as damaging as tornadoes.
Fantastic. Thanks, Victor. We've had some questions about Lake Michigan in Chicago and just maybe local potential quiet spots or hot spots in tornado and severe weather climatology in northern Illinois, and what, if any, protection the urban area offers or Lake Michigan offers. So, Victor, any thoughts on that?
Well, I think you guys are just as qualified to answer this question. Absolutely. My first thought on that is, you know, you're playing Russian roulette. If you think Lake Michigan is going to hamper or suppress tornado activity, you could be right on some days. But during the biggest of severe weather days, when the wind is from the southwest and we have what's called strong warm air advection, Lake Michigan doesn't play a role at all. I think mostly in the early spring when we get winds that are coming off the lake. So you have basically onshore flow, what we call the lake breeze. If the lake breeze comes inland, then yes, certainly the areas that are behind the lake breeze experiencing the cooler temperatures at the surface are going to have suppressed tornado frequency. However, wherever that boundary sets up as it comes inland can actually be a focus for where thunderstorms might form and have enhanced wind shear. And it can actually be an area of localized enhancement. So the short answer is it can mitigate depending on the weather conditions, but in the strongest of outbreaks where we see these big, strong mid-latitude, what we call extratropical cyclones pass up through the Midwest, and you get into strong southerly warm air advection, Lake Michigan plays no role in suppressing the tornadic activity. And for that matter, either do the buildings in Chicago. There's some, you know, I think urban legends, if you will, that the skyscrapers will somehow stop tornadoes. They won't. You know, if a strong tornado hits them, they will still stand. It's not going to knock them over, but it'll blow the windows out and it'll cause tens of billions of dollars in losses. I just want to take a step back and say the three largest cities in the United States, right? LA, Chicago, and New York. Out of those three cities, which one do you think has the greatest climatological frequency of tornadoes? And if you're saying Chicago, you're right. It's Chicago. So in a way, at again, a very high level, Chicago is what I would consider to be the most vulnerable city because of the population density, number of people, and when you commingle that with our tornado risk. It is a matter of time until the Chicagoland area gets hit by another strong tornado. And when it does, it will be a very, very significant day in Northern Illinois tornado history.
If I may jump in, Victor, you mentioned the lake breeze itself possibly playing a role in where it sets up. And if you know about Illinois tornado history, Northern Illinois tornado history, you know that the worst tornado outbreak on record for this area is 1967 on April 21st. And if you look at weather maps from that day, and even just look at the whole setup there, the track of the low pressure system that resulted in the outbreak of severe thunderstorms and tornadoes kind of tracked in a sense that you wouldn't normally expect the warm front to get hung up, but the lake itself actually seemed to hold up the warm front and kind of basically place it right over the stretch right across northern Illinois. And of course, we had the Belvedere tornado F4 in Oak Lawn as well. So that's a great example of, you know, what Victor says, the vulnerability of this area, that just because we haven't had one, and, you know, Chicago just had a higher end EF1 tornado with peak winds near 110 miles an hour on the day of the derecho. It was actually associated with the derecho in a small scale area known as a mesovortex. Had a, and I know there was a question about that. And so that the lake certainly didn't protect Chicago on August 10th. That's just one example right there. But just in general, the idea that the lake is always going to protect the city is certainly a misnomer. And having the southwest flow or having the lake breeze play a role in where that boundary sets up or hanging up the warm front, and that played a role in terms of the Oak Lawn tornado. And that was one of the worst tornadoes to strike the Chicago metro, as well as obviously the Plainfield tornado. So really, it's just a matter of time, unfortunately, to say that. But, you know, and you could also think back to our last 10 to 15 years or so. We've had some days that had setups that were really favorable for higher end tornadoes within the metro area. November 17, 2013 comes to mind. The supercell that produced the Washington, Illinois EF4 tracked across northern Illinois, produced a tornado in Coal City, which I know I saw a question about Coal City being possibly a local hotspot. They were hit 2 years later by an even stronger tornado on June 22nd of 2015. And then there was another tornado near Frankfort, Illinois, so a south suburb of Chicago. That same supercell tracked across southern Cook County and onto Lake Michigan. It passed over some near south suburbs of Chicago, like Harvey, Illinois, and a few other those near south suburbs. So that supercell basically tracked just south of Chicago proper and produced tornadoes along its path, including a higher end EF4 down in central Illinois. So we were lucky that day. Another day that comes to mind is June 7, 2008. There was a cyclic supercell, a tornadic supercell that was dropping tornadoes basically across Will County, but just so happened to track in such a way that spared a lot of the county, which is a very populous county of over 700,000 people. But it did go on to produce EF2 damage in Richton Park, a far south Chicago suburb in southern Cook County. So, you know, to say that you know the area is immune to strong tornadoes, I think those recent events and near misses kind of speak to the vulnerability of the area as well, and kind of piggybacking on what Victor was saying. And last thing I wanted to say, this is on a different topic. I want to thank some of the people who we know are on the line with us tonight. Danny Neal, who's a friend of the Weather Service, and the executive of Illinois Storm Chasers, also a Weather Ready Nation ambassador. Thank him for joining us, and he's also been a friend of the Weather Service in terms of providing us some of our training content that you've seen in our spotter talks, our photos. The photo that's for this, the advertisement that was for this webinar, and also some videos that we use in our spotter talks. So I'd like to thank him for joining us tonight. And also, we talked a little bit about, Victor talked about where he's from, and just so you know, if you hear any hint of an accent, I'm from New York City originally. I've lived in Illinois and worked here at NWS Chicago since July of 2010, and I was born and raised in New York City in the borough of Queens. So I really wasn't all that familiar with severe weather until I came out here. And I came out in the middle of what was one of the more active severe weather seasons over the last 10 to 15 years, the 2010 severe weather season. So, and Jake is from Nebraska originally, eastern Nebraska. So if he wants to chime in and say hello, he's welcome to as well. And I'll let Matt turn back to some of your questions. Sorry for the brief interlude there.
No, thank you, Ricky. And yeah, I just want to reiterate, you know, you don't have to go very far back. Just think of the Rochelle Fairdale EF4 tornado that we surveyed. You know, move that tornado, you know, 60, 70 miles to the east, and you have a totally different event. Yes, it would still have been strong. Yes, it would have had more casualties, You know, we need to be prepared for these types of events. It's a matter of when, not if it's going to happen. So while we're waiting for another question to come in, I want to show you really quickly a great website. I'm going to chat it to all of you, so you have this link. I have it bookmarked. I also access it all the time, so let me see if I can send it to you. This is the Storm Prediction Center climatology page, where you can look at the daily changes in probability. And so I have the date closest to today's date, March 2nd, pulled up here, that it would be March 4th. And just look at what happens in the daily probability as we move here deeper into the spring. I want you to focus on Northern Illinois and kind of look how our probability changes. You can see these numbers are really low. You're going 0.1%, and even at the highest 1%. Well, you got to remember that tornadoes are very rare, right? It's not very likely to have these. So these probabilities might seem very low to you, but in the grand scheme of things, they're actually fairly high when you start looking at the climatological numbers. Look what happens though as we get into May. So here we go through April. Look at how the northward expand of this contour gets up in really the southern portion of the Chicago County warning area. You're about up to the I-80 corridor here with this hotter orange getting up to maybe 0.6, 0.8 here in terms of probability. And I mentioned earlier on the call that the highest tornado probability in north central and northern northeastern Illinois is actually the first week in June. Take a look at these numbers. Early June here is where we see this kind of corridor of very likely that these warm front events are happening, really ripe from mid-April through mid-June. That is our peak climatology here in north central Illinois. Yes, you can get events outside of that, but if you're looking at the calendar and going, there's a tornado watch today and it's, you know, June 1st, you can bet that that particular day, in terms of the calendar of analogs of history, you know, is very likely to produce a tornado somewhere across that tornado watch box. So bookmark that. Great site here. You can look at all kinds of different hazards, including significant tornadoes, hail, and wind. So with that, I'm going to turn it back to Matt for.
All right, thank you, Victor and Ricky. They're good reminder. Not if, but when violent tornadoes strike northern Illinois again. We've had a couple questions hint on damage surveys, and we touched on them a little bit, and specifically asked about how we tell straight line wind damage from tornadic damage. I wanted to step back real quick and just make a remark on what the goal of damage surveys are for us in the National Weather Service. And we conduct those after impacting wind events, whether it be tornadic events, suspected tornadic events, or high-end damaging wind events such as the derecho last year. We work closely with our emergency management partners as well as academic meteorology partners such as Victor. Damage surveys help us to determine what happened and how strong it was, of course. It also helps us to link research to operations and back operations to research as well, and help us improve the warning process and assess and verify how we did for the event. It's also an opportunity to get boots on the ground and talk with our partners and see if they interpreted our warnings and forecast message and understood what was happening, as well as some of the public. And we hear some amazing accounts when we're out there, and at times we see some really heartbreaking damage as well. So damage survey process is important for seeing an event through and learning from an event. But in terms of determining straight line wind damage from tornadic damage, it's really about the character of the damage that we see, and it depends on what type of damage. We've been trained on various damage indicators, for instance, damage to residences or trees or utility poles, and being able to correlate that with wind speed damage. This comes from research and expertise done in academic sector and engineering sector, as well as by research meteorologists, and that's been trained to the field, and we utilize that to assess what has happened. Sometimes it's difficult to tell whether it's straight line or tornadic, especially when you get in a high-end straight line wind event with embedded tornadoes. And we definitely had that last year in August 10th And we had some of that in the November 10th quasi-linear convective system, or QLCS, as we say too, but certainly with that August 10th derecho. And to some, it may be not that important whether the wind is rotating or it was blowing in a straight line. It damaged my barn or my home or took my trees down. And we are very cognizant of that as well. It helps us, though, in the process to take back and learn for how we approach warnings. And we're always reevaluating that too, going forward as well. But we look at a character of a lot of the damage, not just one or two pieces of damage, but really the whole thing. We also corroborate it with radar analysis as well, and also what the environment was conducive for in that area too, and put that all together. The damage is the most important. Sometimes we have eyewitness accounts too from trained storm spotters, which help as well. Ricky or Victor, anything else to add on determining straight line from tornadic damage there?
No, you covered it really well, Matt. And it always is a challenge to try to figure out which ones you're going to go out and actually survey, especially in a very active year. And, COVID last year, you talk about impacts. COVID actually impacted the way we were trying to do storm surveys, right? To not, stay 6 feet apart and practice social distancing when we're trying to figure out how impactful these tornadoes were. It is just as much, an acquisition of science to try to figure out sort of forensic meteorology, if you will, of what the wind speeds were at the location of damage. And it really is still at this day, the only way for us to really put some bounds, some estimates on how strong the tornado was, because we're not able to do that from radar. So I think you covered it really well, Matt.
I can jump in with something if I can briefly take control of the screen. I have one of the slides from our spotter talks that were given this year. Sure. I could show that.
I'm going to go ahead and give you a presentation.
Make sure it's me. I know we're all all of us are listed as NWS Chicago.
Okay, yeah. See if you have.
All right, I'm gonna pull this up now. And also, there was a question. So before I get to that, I'm gonna briefly. I know someone asked a question about wind shear, so this is the slide from our spotter talk. And so wind shear, this is just a simple explanation of it, and certainly Victor can jump in if there's anything further to add on this. The most important thing to know about wind shear, and just the simple definition, is the change in wind speeds and or direction as you go up from the ground to jet stream level in the atmosphere. And the most important thing to know about wind shear when you hear about it is that weak wind shear leads to those pulsy afternoon, summertime or late spring, warm and humid days with very weak wind shear tend to have shorter-lived thunderstorms that may produce brief downburst winds or maybe marginally severe hail at their worst. And then on the strong wind shear days is when we're talking about events like supercells, such as April 9, 2015, and some of the other outbreaks that we mentioned, as well as wind shear that augmented the August 10th derecho and some other derecho events, including June 30th, 2014. And so that was an event that had plenty of wind shear and ended up being a double derecho day. And we had another similar to what happened August 10th in our area. We had many tornadoes with it. So it ended up becoming not only derecho, but also a localized tornado outbreak. And I'm going to go over to the screen. We had a question about microbursts, and I wanted to tie that into the survey part. So I'm going to call this up here. So one of the things that we use for surveying, this is kind of the advanced prep work that we do for surveying, is that we actually use radar to correlate things. So we can have a pretty good idea if we had a really well-defined supercell, like let's say the Rochelle-Fairdale tornadic producing supercell. We have a good idea of the damage that we're going to find is going to be tornadic, right? So, but it's not always that clear cut. So sometimes we have mixed mode severe weather. We can have damaging winds from straight line or downburst type winds, or we can have at least brief tornadoes on the same day. They can occur with squall lines. They can occur if we're in mixed mode with multi-cells and supercells. So on a more challenging day, we oftentimes look at radar and see we receive reports of damage that we may go on to survey, and we look at radar and try to correlate that to see if we see signs of rotation on radar. I turned to our slide about downbursts because a question was asked about microbursts, and also to show the difference. So briefly, I have a slide here about inferring rotation from our radar. And the radar is the black dot in the middle. Anything that's green, the green colors are air and meteorological particles and non-meteorological particles moving towards the radar. The reds are moving away from the radar, kind of like car taillights. When we infer rotation, we have the greens and red against each other with respect to the radar, and the radar being on the bottom of this picture here. And so when the reds and the greens are together, and we can infer rotation that way, that the greens are moving towards us and the red is moving away, but you can infer that rotation. That's the areas that we're looking for to correlate with damage reports that we receive in terms of surveying possible tornadic damage. When it comes, and this is an example of a really high-end supercell and tornado that occurred down, I guess, in Mississippi. I'm guessing from some of the towns there. And correct me if I'm wrong, anybody that any of the weather service or Victor, but you know, that's an area of the colder colors and the warmer colors together, inferring rotation, and indeed also paired with radar reflectivity, which is on the left. There's a debris ball there, so there was a violent tornado going on this radar image. But then back to this screen here. So this is a radar image from July of 2016 from the Midway Terminal Doppler. And I'll show a laser pointer here. Sorry, I didn't have that up on the previous one. So this is what I'm talking about, inferring rotation in this way, and the inbounds and the outbounds. So going back here, so the radar is here, and we see greens moving towards the radar, and we see reds and other warmer colors moving away from the radar. And the more intense these are, is signs of really high velocities on our radar. So what we have here is actually a downburst, and a type of downburst called a microburst, and it's only called that because of the small. It has to be a certain, well-defined small area that receives these damaging winds. So what happens with a microburst, and think about a tall thunderstorm above this area, it all of a sudden collapses, and an updraft collapses, and the air hits the ground rapidly in this general vicinity and then spreads out from a point. It fans out. And that area where it hits is kind of usually the focus for damaging winds in this microburst. In the case of July 24, 2016, we had damaging winds, particularly damaging winds in Blue Island in southern Cook County. And based off the tree damage there, probably at least 80 to 90 mile an hour winds briefly occurred with this. We also had 60, 70 plus mile per hour winds in other portions of Cook County this day. But I just wanted to show that. So if we receive reports of trees down and people are saying, oh, is this a tornado? And we're asked questions by the media, that can inform our ability to discern before we even go out and check it out that it's not going to be a tornado, because we have air moving towards the radar and away from the radar, and not together in a way that infers rotation. We see air spreading apart, and that means it's not rotation, it's actually a downburst, a microburst. So we'll know beforehand that the damage report that we receive is that of damaging straight line winds. So we can actually be confident in telling the media that before we even send someone out to check out the wind speeds that cause that damage. And sorry for taking a little bit there, but and also it's now a little bit after 8. We said 7 to 8, but Victor kind of already hinted at it, since we got many questions from you, and I know everybody was excited to take part in an event like this. We'll be able to stick around probably till about 8:30, and we can answer more of your questions, or if we see similar questions, we can answer them in a summary format, those of us that are on the call from the Weather Service, and also Victor. So I'll hand it back to Matt for some of your questions.
Yeah, let's take some more questions.
All right, thanks there, Ricky, and we will be answering some of the questions just directly in text, as we won't be able to get to all of them. So you should see some answers going across to questions as well. I'm going to turn it over to Jake here real quick. I know, Jake, you've been catching a lot of the questions here. Did you have one or two pop up there you wanted?
Yeah, there's one thing that kind of a couple questions were referencing where to take shelter, and then one in particular referenced that they live on a second floor apartment, and the place where maybe they go under the stairs is next to either an exterior wall or a garage. And I was curious if either you, Victor, or Ricky had thoughts to add on how people should determine where is the safest when every situation is slightly different depending on where people live.
Great question. I really have two rules. The first rule is to get to the lowest location possible. So that's the lowest floor that you can possibly get to. If you're on the second floor in an apartment complex, it's probably a really good idea to try to make good friends with your neighbors. If you don't feel comfortable in the structure that you are, then don't wait for the tornado warning to be issued. Start taking action when there's a tornado watch, when the conditions are favorable, and be thinking about what you're going to do on a particular day when severe weather is expected. Don't wait for that warning to be issued, and the fact that, you know, yeah, most warnings are going to give you 10, 15 minutes lead time, but maybe you don't have that type of lead time, right? So I always say, if it's possible, get to the lowest floor that you can. Number two, that's number one. And the only other thing that you need to remember is put as many walls between you and the tornado as possible. So number one, lowest floor. Number two, as many walls between you and the tornado as possible. Cover yourself up with blankets and pillows if you can. You know, certainly if you have a basement, getting under, you know, usually there's stairs down to the basement, right? Getting up, tucking yourself up underneath those stairs, or a bathroom in a basement, you know, something that doesn't have windows generally. But man, if you could just get to the lowest floor and put as many walls between you and the tornado as possible, that is really going to increase the probability that you're going to survive, even in violent tornadoes. If you look back at some of the worst tornadoes in history, EF4s, EF5s, people survive in those paths, and they're not underground. They're just on the lowest floor, they're not necessarily a basement, and in an interior closet or a room, and they survive. So you really actually do have a pretty high probability of surviving even in the most violent tornadoes, as long as you take those precautions. We know that there's places you don't want to be: in a vehicle, in a mobile home, right? Any weak frame housing stock, not good, right? But in general, most homes are going to be adequate. And then places like you're out shopping, right? In these shopping malls, what do, right? What's your severe weather safety plan when you're out? You know, many of these places will, you know, if you're in a grocery store, will usher you into a cooler. But don't rely on other people to make your severe weather plan for you. You need to take this week, Severe Weather Preparedness Week, and make sure that you're prepared by thinking about where you're going to take shelter, no matter what you're doing. And again, I always tell people that don't wait until the warning is issued. Do it now. And then, you know, certainly if you feel like you're going to be traveling, you know, make sure you're aware of the forecast. If a tornado watch is issued, make sure you have a plan no matter where you are. But that's the best possible advice that I can give you.
And am I still showing my screen?
You are
there,
Ricky.
Tornado
Yep.
safety stats. Yeah, that's great. Yeah, I mean, those are all, I think, reflected in sort of what I'm mentioning here. Some people are getting creative in their little safety kits. They're putting a bike helmet in there. You know, a lot of the injuries that we see, and fatalities for that matter, in tornadoes are blunt force trauma to the head. And so, you know, I can't say, you know, if you can find a cheap bike helmet at a garage sale, throw it in, certainly throw it in your severe weather safety kit. Cover yourself up with some pillows. You know, it's going to be the flying debris and that sort of thing that's going to give you the injuries. But again, if you can get the lowest floor and put as many walls between you and the tornado as possible, that's, again, in most cases, you're going to be just fine.
And along that point, we were asked about, you know, if you're in an apartment building, whether it be a high rise or a small apartment building, thing to keep in mind is that a lot of these buildings are pretty well fortified as well, and you know, you can have instances of tornadoes that are strong enough that they can produce significant damage even to those structures. But you know, one of the things that we'll be providing in updates to our warnings is the type of tornado we have impact-based warnings. We talk about particularly dangerous situations, and we haven't. I don't think we've issued one here since I've been here. A tornado emergency. That's something that's a reserve for the catastrophic type damage potential based off visuals and reports and on radar presentation. But if you follow these steps, if you're in a fortified building and you get into the most interior room, even if it's not perfect or not exactly the lowest floor, you're probably going to be okay. I don't want to say that to be complacent about your own safety. What I mean to say is that your chances are pretty good if you follow these safety steps. And up on my screen, I have the slides that we shared on Facebook, and we have this sheltering guide that was released a couple of years ago, I believe in concert with FEMA, with engineers, that showed worst options, mobile homes being one of those, under a highway overpass in your car, which is why we say don't try to outrun tornadoes. Manufactured housing, and large open rooms like gymnasiums. You probably heard about some school gyms being completely destroyed by tornadoes, and then your good and your best options. And then we have nowhere to go when you're sheltering. Mobile homes, I wanted to turn back to that. And this is a way to think about mobile homes. If any of you on here live in a mobile home or know someone, have loved ones in it or friends in a mobile home, that mobile home is just, it's basically not a shelter whatsoever. So a good way to think about a mobile home in terms of safety is, I have it on this slide here, consider heading to a location with a safe shelter during the tornado watch. So anybody you know, or if it's yourself, I'd say know your safe place prior to warning time for tornadoes. When you're during the watch, I mean, have this figured out well in advance. Know where you need to go. Know where the mobile home park has its better shelter. If not, know a place to go to take shelter, and do that during the watch instead of waiting, because if you wait and the tornado is bearing down on your location, it's pretty much too late. So I did want to point that out as well. And also to Victor's point about using blankets and helmets, etc., and pillows and everything. We show this slide, and we're not saying to joke around. It seems kind of funny, but any sort of helmet that you have, the number one way that you could get severely injured or tragically, people get killed is head injuries from flying projectiles. So anything that you can have to protect your head is huge. So wear it, wear any helmet you have, a bike helmet, a football helmet, any sort of helmet, a motorcycle helmet, and bring a bunch of pillows and blankets, etc. And also, Victor pointed out about, if you don't have a basement, how you could still be okay. There's a photo that we have that we've used during Severe Weather Preparedness Week from the Ottawa Naples tornado that happened 4 years ago on February 28th. It was individuals in a house in I believe it was in Ottawa or native. I think it was Ottawa. Their house sustained significant damage, but they were sheltering in the bathroom and covering themselves up, and they were okay. And there's a photo of that bathroom basically standing with the other walls around it collapsed. So
yeah, I'll never forget that event. I surveyed that tornado and talked to that family. They were on a one-story, no basement. Got to the interior closet. We walked up to the home, and they showed me where they sheltered in this small closet with pillows and blankets. It was the only part of their home left standing, this interior closet, and they were just fine. But they got to that interior room.
Yep. All right, so I'll let Matt or Jake get to some more of your questions, or again, a summary. So if we're not directly addressing your individual question, or we haven't answered it yet directly back to you or to the audience in the interface, we are trying to do the best we can to get to several more questions in the time we have left. And I said 8:30 about, so we'll try to summarize things that are similar questions, and we'll try to get to what we can by answering back to you, and then we'll try to cover the rest here as well. So Matt or Jake?
Yeah, thanks, Ricky. Early on, there was a question about how someone can monitor for severe potential days out. And one thing we recommend in our spotter talks is kind of doing a weather check each day. It seems like an ideal time in the morning, kind of looking at the next 7 days of the forecast. And there are some sources of information. There are actually a lot of sources of that information. But maybe, Ricky, if you did want to just show on our homepage, for instance, our weather story graphics, for instance, and or the GHWO. We in the Weather Service are always looking out 7 days. in concert with the Storm Prediction Center there in Norman, Oklahoma, that Victor showed some graphics and climatology from. They are always analyzing severe weather potential, and we're always analyzing on the local front any hazardous weather potential over the next 7 days. So we put out some information, forecast information that always goes out 7 days, and with particular emphasis on any hazardous weather potential. As Victor said, when a warning comes up, and if that's your first time changing your mannerisms at all on that day of severe weather potential, it may be too late, and it likely is too late if you're a decision maker or overseer for a lot of people. So knowing when there's severe potential coming is really important, again, especially for decision makers, and that includes just simply head of households, but you don't want to get yourself in a bad situation where it takes you too long to get to shelter. So it's important to have an idea that, hey, there's a severe weather threat, for instance, say Friday, and then when it's Thursday, the next day, and I see there's a little more detail, it looks like it's going to be after dark, and then on that day, checking in more often than once a day with your forecast. So Ricky, here, you've got our homepage up here. I'll let you say a few words on where people can get forecast information days out from here.
And I wanted to mention that is my screen being shown right now?
It is.
I think it's actually me. I'm sorry.
I'm sorry. Sorry there, Victor.
No, it's okay. I can navigate. I know this pretty well, but we have everything right from the local forecast to long range as matter.
Victor, you see an issue with, okay, our weather stories are up. When on my end, there was a glitch going on, and that referenced our weather stories on the bottom left, and those are a good one-stop shop, kind of packaged in a way that we can kind of cut to the chase of things. Obviously, if you're a power user of our information, then you can look more in depth at various places on our website. So one thing we'll do is we'll often do a 4 or 5 day outlook, but it's so quiet this week that we looked ahead to next week when we may get into an more active weather pattern. And that's kind of hinted at by what Victor started our talk with about our outlook for moving out to the next 1 to 2 weeks. And the graphic that was briefly there showed a climate prediction center outlook showing us in elevated probabilities of above normal precip. And just looking at the model and ensemble data at that range and some other longer range indicators that could also be paired with thunderstorm activity, depending on how that all evolves. Obviously, warm fronts usually dictate in terms of surface-based convection. But we can certainly get elevated thunderstorms north of the warm front, and so it could be our next best chance for appreciable weather is going to be sometime during next week, which could include thunderstorms. And as Victor mentioned earlier, we're not, we're in the possible threat zone for severe weather activity this month, which could be elevated over the next couple of weeks. And I'll let Victor kind of click around at some of our. We also have our hazardous weather outlook. That's on under current hazards.
Yeah, sorry. You can get under the forecast tabs. If you go to weather.gov/Chicago, under forecast, you can get to this is what I do every morning. If you want to know what I do every morning, I brush my teeth and I read the area forecast discussion. That's a really good way to catch up. It's updated, again, daily basis. If there's active weather, sometimes these will get forced updates to basically, discuss something that's coming down the pike relatively soon. They are geared a little bit more to, the meteorologically savvy, I would say. But this is actually how I grew up learning about meteorology. I would read these forecast discussions from excellent forecasters. And again, you can cruise through all offices around the country, wherever there's active weather, to kind of see what's going on. But the forecast office in Chicago does a great job with these, and I strongly encourage you to read these, especially as we go through severe weather season. These in conjunction with SPC, the Storm Prediction Center. So their website is spc.noaa.gov. They have on their homepage, you can click on the Convective Outlook tab, and again, they have outlooks for the next 8 days. And as we get through the season, you'll see these bounce around. You'll see hot spots begin to flare up. But at the end of the day, these are basically just a scale. If you look at the categorical outlooks, a scale of 1 through 5, kind of like, the Homeland Security terrorism threat level on a scale of 1 to 5. What is your threat for this particular day for severe weather? And we keep it easy, a scale of 1 to 5. And you know, when you get up to these, you can get tornadoes even in ones, right? So you can't let your guard down when you're just in a thunderstorm or a marginal. But as you increase your numbers from 2, 3, 4, and certainly as you get to 4 and 5, these are the events that, if you look back historically, produce the most prolific events. So yeah, definitely use these types of forecasts to your advantage, whether you're planning your week, planning your day. And I don't think I want to leave this webinar without reinforcing the fact that you want to have, obviously now information spreading with WIA alerts over your cell phones, but make sure you have ways to receive watches and warnings. It's so important to just stay informed. So some more questions maybe?
Yeah, there's still a handful here. It was remarked how the peak time of tornado climatology during the day is around that afternoon rush hour time. It's also a time of after school activities, for instance. We think of early summer, as Victor showed, June time, a lot of outdoor events could be going on too there. So this resonates the importance of knowing the forecast in advance too, and not getting necessarily caught in a bad situation, for instance, in a vehicle, for instance, or when severe weather strikes. But if you are in a vehicle and your wireless emergency alert goes off, for instance, what should you do in that situation? There are a couple questions kind of hinting at that. So I'll open that up here to the group here to talk about.
That's a really challenging problem. We're a global society. We're on the road. We do things. We take risks. We perhaps know there's a chance for a severe weather that day, and then you're in a vehicle and it goes off. First of all, I think it underscores the importance of knowing geography and knowing space and place and time, so that you can immediately recognize that there's a threat coming from WIA. If you're getting WIA, it's very likely that you are either inside or very close to the polygon that's being drawn out of the National Weather Service in Chicago office. They're not going to put you in that. They're issuing the polygon because they feel like areas in and near that polygon have a risk of experiencing threatening weather, whether that be severe thunderstorm warning, where you can still get tornadoes. I think that's a myth, right? Just because you're in a severe thunderstorm warning doesn't mean you can't get tornadoes. But certainly if you're in a tornado warning and your WIA goes off, this is where situational awareness becomes extremely important. Where is the storm relative to me, right? Observing the sky with your eyes. One of the best things that you could do is invest some time during the spring and go sit in on a severe weather training seminar, spotter training seminar, and just learn about basic cloud formations, patterns, and visualizations of how tornadoes form in storms and what to look for. That way you get yourself in a situation where you're not driving into a tornado producing storm. Generally speaking, even in Chicago where we have buildings and trees, this probably active severe weather is coming from some component from either northwest, west, or southwest. Right? It's very rare to get a tornado or a storm coming out of the easterly component toward the city. But understanding that where that threat's coming from, the ability to drive out of the way. If you're getting a WIA alert and you're already in the tornado that you feel like your life is in immediate danger, you have to try to figure out a way to get out of your tornado and get out of your vehicle, because your vehicle is going to become a missile if it does get hit by the tornado, and get into a low-lying ditch or a culvert or some other protected, if there's a building nearby, a business, run inside and try to take shelter. But please do not stay in your car if you feel like your life is in danger of being, your vehicle's in danger of being hit by a tornado.
And I think that underscores really this whole idea of awareness, being weather aware, being weather ready. And one of the few silver linings of this year that we've all been through is that a lot of places have really ramped up their remote capabilities, the ability to work from home. Even us at the Weather Service, we've developed that capability for support from our teleworkers which we really hadn't done before, and it was kind of necessitated by the pandemic. But the idea that you are knowing in advance that what possible time of day could be threatened, we'll put up graphics with severe weather threat times, with thunderstorm threat times. So if you have the ability to be home at a certain time and not be out on the road, that's a great way to be safer in that spot and not be put in a spot where where your phone goes off with a WIA and you're stuck in traffic.
Yeah.
And that's it right there, is not being that spot. So we try to do the best we can in the weather service, the whole weather enterprise, the TV meteorologists local from Chicago and Rockford that we work closely with, partners down in Central Illinois. We have TV stations down there that will cover obviously portions of our forecast area. Also academia. Victor will post stuff going into to his followers going into a severe weather event, you know, being from the area and working at Northern Illinois University, that we try to ramp up everybody's awareness, and that's incumbent upon you as well to take advantage of this information that you can have at your fingertips and allow yourself to be in a spot, you and your family to be in a safer spot if disaster is possibly about to strike. So meaning, you know, it's not just, oh, get out of your car, dive into a ditch, because a ditch is the least bad option at that point. It's not a good option. I would never call it a good, it's the least bad option. We always say that. And to be home where you can safely shelter. And again, the ability to work from home, and not everybody has that, but if you don't have that ability, it's always knowing the road network. If you're not at a place that has a safe shelter, know where to go immediately if a tornado is bearing down in your area. You got to know where to go at all times. Know geography, know the road network, and if you can do it, take advantage of being home if we're warning about a possible higher end severe weather threat and the time of day in which it might occur. And the final note I'll make about WIAs is that this year there's going to be a service change again to that for higher end severe thunderstorm warnings. We're going to have the ability to use damage threat tags just like we've been for tornadoes for the last 7 or 8 years. And so we're going to have higher end damage threat tags that would get WIA alerts. So I think it would be for damaging winds and probably giant hail as well. So a good example of that would have been the August 10th derecho. Portions of eastern Iowa, including right around Cedar Rapids, had surveyed, the Quad Cities office surveyed that area, and there was wind speeds there, at least briefly, that were upwards of 130 near or upwards of 130 miles an hour. So you think, oh, you just got a severe thunderstorm warning. Well, we're going to have the ability for that sort of situation to issue a higher end warning that would activate WIAs. And therefore, when you get one of those, know that it's a really high end situation, that's not just a run of the mill, you know, not that we don't want you to treat any severe thunderstorm warning as run of the mill. 60-mile-an-hour winds can take down tree branches, can fall down on top of cars and motorcycles, etc., people riding bikes or walking. But a high end event, 100-mile-an-hour winds, 90, 100-mile-an-hour winds, is basically hurricane winds or tornadic-like winds. So it doesn't have to be a tornado to be extremely dangerous and life-threatening. And so we'll have that ability. I think that change is coming August 28th. And anybody on here from the Weather Service can correct me if I'm wrong on that. I think April 28th is going to be the service change for higher end severe thunderstorm warnings to get a WIA activation. And I'll turn it back to Matt or Jake.
All right, thanks, Ricky. And yeah, we're nearing the end here, so may only be about one more question or so. And again, Jake and I are trying to respond to the others here via text here.
Just really quickly too, for those of you who don't know what WIAs are these wireless emergency alerts, right? That we get them for Amber alerts. You get them over your phone. You're in the middle of a restaurant, your phone starts going crazy. Those are the alerts coming from the National Weather Service that are getting pushed directly to your phone. And to Ricky's point is we've only done those in the past for flash flood warnings, tornado warnings, and Amber alerts. And now we are going to start doing those here in late April with the most severe thunderstorms. So if it meets a certain threshold, the Weather Service is also going to send you alerts for those as well, which I think is a really, really great move. And I think the derecho last year sort of forced our hand at definitely being able to do that sort of warning. So kudos to the National Weather Service to get that implemented. So maybe 2-3 more questions if we have any. Otherwise,
yeah, sounds good, Victor. And what you mentioned about the derecho is climatology. We are in a hot spot in this part of the country, so it's good to have those wireless emergency alerts coming for higher end severes. On the note of powerful severe thunderstorm wind complexes, there were some questions about quasi-linear convective systems, or QLCSs. These are features we've gotten to learn more about in the past really 5 to 10 years, especially as we've gotten more higher resolution data, both radar and satellite data after the fact. And these events have embedded tornadoes within them often. They almost always have embedded rotation areas, and whether or not they produce tornadoes can be a challenge, or at least long enough rotation areas that can be evidenced after the fact. Here at Chicago, we've had multiple of these events that have been somewhat noteworthy, and we've done some partnering again with an academic partner, Dr. Tony Liza, a little bit with assessing that type of damage and using different attributes after the fact to try to piece together what is straight line wind damage and what is rotation in tornado areas. During these events, there was a question on, do we have more of these tornadoes now that we are seeing more higher resolution radar data than we had before? And I may toss that over to you, Victor, on the climatology front. I will say on the surveying front, as mentioned earlier, we do corroborate our data, our damage data with radar data to help piece together everything, as well as eyewitness reports too. But Victor, if you want to speak a little on, if you wanted to, on the climatology QLCS tornadoes in this part of the country.
Sure. No doubt we probably miss hundreds of tornadoes every year that are spawned out of these quasi-linear convective systems. They are a warning nightmare. They're very challenging when you're on the warning desk. They're very much like playing whack-a-mole. They can spin up on the order of a radar scan and be gone by the time you draw the polygon and issue it. And that's why, interpretation of radar, or even just paying attention in severe thunderstorm warnings, is really important. The climatology for those generally happen along and east of the Mississippi River Valley. QLCS tornadoes can happen at night. They're just, overall, they're really dangerous. And they can be, although they're not always, and I'd say majority of them are not, but they can be significant, what we call EF2 or greater. So get up there on the Fujita scale. It's certainly not a majority of those tornadoes, but some of them can be significant, and they do cause casualties. They cause injuries and fatalities every single year, and they are definitely tornadoes that we have to be aware about. I think we're obviously detecting more of them now with better Doppler radar resolution, level 2 data, the ability to see these scans with better temporal resolution. So yeah, we're detecting more of them, but we're probably still missing hundreds of them every year when it comes to climatology. So definitely not not what you're going to see when you open up a textbook and search for the word tornado, right? You're not going to see a QLCS tornado. They're typically embedded in precipitation. There might be a little kink in the line where you can visually see some rotation, but generally speaking, that's why they're not well documented, because they're really hard to see visually. And they're also they're tough on radar as well. They're just a warning challenge. And even if you're looking at radar and you're going, why did the Weather Service issue that warning? That's just a line of thunderstorms. There could be embedded rotation, and those storms can be dangerous.
And also along the line of the WEA issuances, it's not something that's meant to say, oh, the Weather Service was getting too hard for them to issue them. But Victor had already noted that it's very challenging to issue warnings for tornado warnings for QLCS situations, and part of that is that they sometimes are very brief but can produce pretty intense damage. In fact, some of the work that we've been behind the scenes is looking in great detail at the 2014 event I referenced earlier, which actually had in the Kankakee River Valley, actually had some EF2 type strength tornadoes. A lot of people forget that on April 27, 2011, the historic and one of the worst tornado outbreaks on record for the United States, there was actually a QLCS that produced EF3 tornadoes in the early morning hours in Alabama and Mississippi. And so to say that, oh, they're QLCS, they're just going to be weak. Yeah, well, you could have a bunch of weak ones, but you could also have strong ones. And the ability to warn on them is challenging. So if we're in a situation where it's rapidly evolving, we know there's potential for embedded rotation on the leading edge of these squall lines and derechos that we could issue if we also are confident that we're getting 90, 100-mile-an-hour winds, non-tornadic winds, but also likely getting at least brief tornadoes that would probably get a high-end severe thunderstorm warning and possibly targeted tornado warnings as well, which any of those would activate wireless emergency alerts. So, and we definitely miss them, but we try to do the best we can in terms of documenting these events because we have the ability to see more of them on radar and corroborate. But it is still a challenge, and we still do miss some of those as well. And I'll turn it back over to Matt or Jake if we have one or two more before we have to go for the night. And if you had a question that we didn't get to, sorry for that, but we hope you enjoyed this session tonight. This is something we hope to do again in the future. This has been a lot of fun. This has been awesome having Victor with us tonight. So we don't want you to feel discouraged if we didn't get to directly answer your question. We also, if you have any burning questions, there's ways to email us directly, and there's 100 people still on the call, so you're welcome to do that as well. But I'd like to thank everybody for joining us tonight. This has been so much fun doing this and having this opportunity to speak to you tonight about what we're passionate about. So Matt or Jake, last one or two questions.
Yeah, sounds great.
Yeah, I think we're pretty good here. Jake, did you have anything you saw that was really standing out? I think we kind of grouped several questions together and they were covered.
Yeah, I saw there were a few questions kind of relating or tying back to soundings and that sort of thing. I didn't know if either of you had something that we could direct people to kind of learn more about some of the maybe more challenging weather topics that we can't exactly address everything in a Q&A session like this, such as soundings or weather terminology.
Yeah, I'll post a link here to the NWS jet stream, particularly the skew T-plots page, which is another term for soundings there. And that can be a reference here. You'll see that come across here. But when Jake mentions soundings, he means our weather balloon launch data. As the weather balloons ascend, they take data. Also, we look at model forecasts of the vertical profiles of the atmosphere, or soundings. And those are very important to determine what both Victor and Ricky talked about: wind shear, but also instability and moisture as well. So vertical plots of the atmosphere are essential to us in convective and severe weather forecasting.
And I'd be remiss to if I forgot to mention that Victor's Victor and his meteorology students have done soundings for us on severe weather days from out in DeKalb. So huge for them to help us out with that. And also Valparaiso University, also students there, we get sounding data from them as well. So we have soundings from the Lincoln office, from the Quad Cities office. Those are the nearby weather balloon sites for our area that we utilize in assessing severe weather potential. Also, we have the ability to look at aircraft sounding data usually from planes flying in and out of Midway Airport, also some of the planes flying in and out of Rockford Airport. And finally, also sounding data from academic partners as well, which is huge for us to have those because we don't have any point-based sounding right over our neck of the woods over here. So, to learn more about that, I would certainly go to that link that Matt mentioned. And if you're wanting to know more about advanced severe weather topics, one thing I mentioned last night, if you were on the spotter training webinar, is the NWS Norman YouTube page has some really great spotter training videos that are up on their YouTube channel. And you could also look up their advanced spotter training topics. So if you were on a previous talk, we didn't mention those, or if you're just interested in learning a lot more about some of the things we spoke about tonight or some advanced spotter topics, I would highly recommend going to their YouTube page. And also, we're hoping to provide an advanced type severe weather training or spotter training webinar sometime later this spring, and we will certainly announce that on our website and on social media when that time comes. So if there's no other questions, are there any?
I think that's good here, Ricky. I think we got to most of them. And again, thank you so much to everyone for posing some absolutely fantastic questions and for sticking with us here for a little over an hour and a half.
And once again, thanks, Victor, for joining us. We got to do this again. I know there was a question. I don't know if it was directly answered, but is there any sort of things like Fermilab or the DuPage Advanced Spotter class or a seminar, DuPage Advanced Severe Weather Seminar? Is there anything like that planned? We can't really say that right now that there's anything like that planned, but since we've had a lot of success with this format, I think this is something we can look to as a possibility of joining forces with academic partners, et cetera, maybe even some of our TV meteorologist partners in terms of holding something like this virtually. And I think just with the ability that we've shown to be able to hold these and have everybody's interest and get great feedback from them, that we could do this sometime in the future. And that all being said, we're gonna have to go for tonight, but thank you again if you're still on with us. And again, always be weather aware. Check our website, your favorite TV meteorologists, favorite websites, such as let's say Academic Partners, Illinois Storm Chasers, another one. Any page that you follow that has great weather information, including us, where we issue the warnings, watches and warnings. So please be weather aware and stay safe in multiple ways as we move here through the next several months. Hopefully not too bad of a severe weather season. And thanks again, everybody. Have a great night. And that's all. Take care.
Yep. Thank you all so much for attending. Good night.